mean value theorem. Small thing we're going to go over today. Okay. So up here is the mean value theorem, already written out for you. Okay. If F is continuous, ooh, I bet that's important, on the closed interval, and differentiable, I bet that's important, on the open interval, then as long as those conditions are met, there exists a number C in that interval A to B, where the derivative at C equals the slope between A and B. Right? Is that slope right there? Is that what that says? Okay. 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 So this seems kind of like, what? There's just a bunch of symbols up there. So we have this crazy picture that we're going to fill in some information for and like really grab a hold of what this is saying. Okay. You're giving me a weird look, Matthew. That's a pretty good one. Oh. Here's our figure. We have X is A and X is B. Let's go ahead and label our ordered pairs. So if X is A, then our Y value is F of A. And if X is B, then our Y value is F of B. Fair enough. Label a segment whose length is F of B minus F of A. Label a segment whose length is B minus A. Talk about that amongst yourselves and figure that out. Okay. Ask you, point to me which one is F of B minus F of A. Okay. This yellow is F of B minus F of A. Okay. And then in orange, which is B minus A. Oh, okay. This guy right here? Yeah. Okay. Cool. The quotient F of B minus F of A all over B minus A is the, yes, it's the slope of the segment joining A and F of A and B and F of B. Yes, very nice, very nice. Oh, draw this segment. This is why I gave you a ruler so that you could draw that segment. I gotta do a brighter color. What's a nice bright color? Orange with orange? Does orange pop out at you? Like that? Is that better? Okay. All right, let's focus. Let's focus. F of C. Oh, no. F prime of C gives the slope of the tangent to the curve at C, F of C. Okay, so there must exist a CF of C whose derivative, aka slope of the tangent line, is the same as this slope. So somewhere on this curve, the tangent line has the same slope as that green line. Draw it. Okay. What are true? What are true? That makes sense. What is true about these two lines? They're parallel, and they're parallel because their slopes are the same. That's the whole point. Okay. There are going to be two parallel lines. One through the points at AF of A and BF of B, and the other tangent to the curve through the point CF of C. Okay. In other words, the slope of the tangent line is equal to the slope of the secant line. Or if you want it a different way, the instantaneous rate of change is equal to the average rate of change. So great. Doesn't it? Okay, there are going to be times where they'll either ask you to verify MVT, or they will literally say, find where the average rate of change equals the instantaneous rate of change. Still MVT is just said a different way. Wow, turns out rulers maybe aren't my best idea. Okay. Please read through Rawley's theorem. Please read through Rawley's theorem. Quietly, silently, in your head, read through Rawley's theorem. Oh, it's what we just talked about, except what's special about it? Okay, it's just more specific. Our slope is specifically 0. So our function values are going to be the same, which means our average rate of change is 0. And so our slope's going to also be 0. Okay, if you can do mean value theorem, then you can do Rawley's. All right. Oh, what? For Rawley's theorem, they need to be the same function height. Okay. All right, I would like you to turn it over to the back and real quick, yours says 5 minus 3x to the 3/2. Please change it to the 2/3 power. Whoops, typo. Before the copies were made. Fixed after the copies were made. Life happens. Okay, what are the 2 conditions that need to be met before we can even consider looking at the mean value theorem? 1, continuous on the what interval? Closed interval. Somebody, what's the second one? Okay. Yeah, differential on the, okay. So, are we continuous on the closed interval -1 to 1? I don't see any place where we would have a polar and asymptote. Do you? No. Okay. We're gonna make it. We're gonna make it. Differentiable. Are we differentiable from -1 to 1? Well, you know what? We're gonna need the derivative anyway. Let's go ahead and find the derivative. Okay. F prime of x is -2x to the -1/3. Are we differentiable from -1 to 1? Oh, this derivative is undefined at 0. We cannot apply the mean value theorem because this function is not differentiable on the interval -1 to 1. Pretty much. Now, question for you. What if, let's just say, I change this to the interval 0 to 1? The bracket includes 0, but we would need to be differentiable on the open interval. So since our differentiable would be 0 here with a parentheses, we'd be okay on this interval. Okay. Now, are these things that you're sort of thinking about in your head? Yes. But on Friday's test, I better see that you thought about continuity on the closed interval and differentiability on the open interval. Like, I need to see that thought. Okay. Are you done with your conversation? Okay. I didn't want to be rude and interrupt. Okay, this one right here. Is this function continuous? Yeah. Everywhere, right? It's a polynomial. Also, since it's polynomial, we know that it's differentiable, okay? Obvious, because it's polynomial. It took me longer to write that down than to think about, but I still need to see evidence that you thought about continuous and differentiable. I will give you a point for writing that down on Friday. Yes. 1 point for both. Okay. All right. So now we want to know where the average rate of change is equal to the instantaneous rate of change. Okay, basically, we need the slope between these 2 points. So we better find the y values before we do that, right? Okay, so what is f of 1? What's f of -1? Okay, so our slope is 3 minus -3 over 1 minus -1. What's our slope? Okay, so we have our slope. Now we need our derivative. Cole, what's our derivative? Okay, and we want to know where our derivative 3x squared plus 2 equals our average rate of change 3. Algebra, just cute algebra. So x squared equals 1/3. So x is plus or minus the square root of 1/3. Are both of those numbers in our interval? Okay. Then here are the c values in which our derivative, our instantaneous rate of change, would be 3, which is our average rate of change on our interval. Okay, now it's possible that you could get 2 numbers and one of them's in the interval and one of them's not in the interval. I only care about the ones in the interval. Okay, so make sure you pay attention to that in your homework. Hint, hint, wink, wink. Okay, now let's talk about Rawley's theorem and how it's the same, but a little different. Okay, so determine if Rawley's theorem applies for this function on this interval. Okay, so same thing we did before. Continuous on the closed interval, differentiable on the open interval. Is this polynomial continuous? Is this polynomial differentiable? Okay, where you're going to need to be careful with those is if you have any sort of denominator. Okay, denominators that are 0 will create our function to have poles or asymptotes. In our derivative, denominators that are 0 create not differentiable numbers. Okay, so we're good here. For Rawley's theorem, we still need our function values. Okay, what is f of -3? Nine minus -6 minus 15. I'm getting 0 over here. Right? 9 plus 6 minus 15. Yeah. Well, that's a good thing because we are talking about Rawley's theorem, right? Since our function values are the same, that means our slope is 0. So now we want to know where our derivative, 2x minus 2, is equal to that slope. I mean, really, we're doing the same thing, but we got a way cooler slope, 0. X equals 1, is it in the interval? Sweet. Why are rulers such a problem for you 11th and 12th graders? Just put them down, we're done using them. It's not your fault that you are distracted by the ruler. Therefore, it is your fault. Okay. I would like you to take 2 minutes to read through and then discuss this last problem at your pod.
That's it? That's just 5 hours? Yes. 5 hours. So, why am I there? 5 hours. Because the 2 points are.
Is it? Okay.
Yeah, we're American, so it has to be done. I don't believe it's Celsius. But I always think it's
Okay. So did anybody do any math during this discussion? There was no math to be done. Okay. So we know, I know, but you didn't do any math in your discussion? So we're 1500 degrees Fahrenheit. And 5 hours later, it's 390 degrees Fahrenheit. So our average rate of change is what? 1500 minus 390 over, well, I probably should have done that backwards. Hold on. Negative 222 degrees Fahrenheit per hour. That's our average rate of change. Okay, well, what do we know about a function that deals with temperature? Okay. Is continuous and differentiable, then by the mean value theorem, there must exist a t-value in between 0 and 5, where the instantaneous rate of change is negative 22. Okay. Now, some of you may have talked about something like this in science, but there's totally a calculus explanation for it. Okay. Okay, since this is your last book assignment of the semester, I'm going to just let you get started right now.